Okay, so today I'm just going to go ahead and go over stoichiometry. I have a lot of students that struggle with this topic, so I just wanted to make a video on it. So we are told that you have 6.50 grams of aluminum that react with excess oxygen. How many grams of aluminum oxide are formed? So the first step whenever you're solving this kind of problem is to make sure that your equation is balanced. Now, I will make a separate video for balancing equations, but I will also briefly show you how to balance this one. So a lot of my students get confused, so I usually suggest to draw a little chart. And I'll put an R right here and a P right there. So R stands for reactants, which is pretty much the left-hand side, and P stands for your products, which is your right-hand side. So looking here, we know that we have 1 aluminum on the left and 2 oxygens. And then on the right, we have 2 aluminums on our product side and 3 oxygens. So the first step that I usually like to do is I usually like to look at these and be like, okay, well, what do I have to do to make them be the same? So I know that on the first hand side, I just have to multiply this one by 2. Okay, but on here, I have to multiply, for these, the most common multiple between these would have to be 6. So this one I would have to multiply by 3, and this one I'd have to multiply by 2. Now, oxygen is by itself in the reactants, so I can put a 3 here easily. But on the products, our oxygen is also with aluminum, so it will affect our aluminum total as well. So I'll do that first. If I do that first and I put a 2 here, now we have 6 oxygens on the product and 6 oxygens on the reactants. 3 times 2 would give you 6. 3 times 2 would give you 6. But the aluminum on the right-hand side is now, instead of being 2, it's actually 4. So we would actually have to put a 4 in front of this aluminum so that they are balanced. So whenever their elements are bonded to one another, usually you want to approach those first and then approach the elements that are single. Okay, once you do that, then we're going to go over pretty much converting our grams, and we want to convert it from grams of aluminum, which is your reactant, right, to our grams of aluminum oxide, which is our product. So whenever you're approaching these type of problems, I always like to refer to the stoichiometry map, and eventually you'll get a hang of it. So here we're going from, they're asking us to go from our mass of aluminum, which is going to be our A in this case, to our mass of aluminum oxide, which is B. So we just kind of have to follow the road straight down. So in our problem, we're told that we have 6.50 grams of aluminum, and then we want to convert to grams of aluminum oxide. So for first, we have to go from mass of aluminum, which is given in grams, right, to moles of aluminum. Now, the main thing that converts grams to moles is going to be our periodic table. And in our periodic table, whenever you look at an element, it'll list its atomic number and it'll list the mass. So the mass is just the number of protons plus the number of neutrons. And the atomic number is usually just the number of protons. So we're going to go to our periodic table and we're going to look at what is our mass of aluminum. So looking here, we can tell that the mass of aluminum it tells you Al says 13 and 26.98. This is going to be our mass. So 27 is our mass, and so the atomic mass is always given in grams per mole, and it's always per 1 mole. So in order for us to have the moles of aluminum, we have to put it on the top so that our grams of aluminum on the bottom will cancel out. So we have 27 grams of aluminum, because 27 is grams per 1 mole. And now we've gone from grams of aluminum, or grams of A, to moles of A. So now we have to convert from moles of A to moles of B. And whenever you're doing that, I like to call that the mole bridge. But that's the same idea as looking at the coefficient. You have to use the mole ratio. Now, looking at our coefficient, we know that for every 4 moles of aluminum, we get 2 moles of aluminum oxide. So we have to put 4 moles of aluminum on the bottom, because we want to be able to cancel those out. This should always be a cross per every 2 moles of Al2O3. Now notice that these two will cancel out and you'll end up with moles of Al2O3, which is close to what we want to get. But we have to convert this moles of Al2O3 into grams of aluminum oxide, so the mass of B. So in order to get the grams of aluminum oxide, we have to once again go back to our periodic table. And we have to go, so we know we have Al2O3. So the atomic mass of Al was 27 times 2. And then we have oxygen, which is 16 times 3. So we end up with something like 54 plus 48, which will end up being 102. So 102 grams per 1 mole. So we're going to go back to our problem, and we're going to want to put our moles on the bottom here, right? So that it will cancel out with the moles of aluminum oxide right there. So we'll put moles of Al2O3, and it's always per 1 mole in the periodic table. And then we're told that we have 102 grams of Al2O3. And these will cancel out and you'll end up with 102 grams. So at the end, you should always have what your unit that you're looking for on the top. And so all you have to do here is we just multiply it. So we'll say 6.50 times 2 times 102, all divided by 27 times 4, which should give you something like 12.3 grams of Al2O3. Great. Let me know if you have any questions.